Hi everyone. In this video, we'll see about the two esterification reactions and its mechanism. First one is Mukaiyama esterification and another one is Yamaguchi esterification reaction. Everyone knows what is esterification. Esterification is the condensation of carboxylic acid with alcohol to form the ester with the elimination of water molecule. Generally, esterification reactions are catalyzed by acids like H2SO4. And the reverse of this esterification is called the hydrolysis. Means when you hydrolyze any ester, you will get the carboxylic acid and alcohol. Generally, hydrolysis reactions are catalyzed by base like NaOH or KOH. Now, what is the difference in normal esterification reaction and Mukaiyama esterification reaction? Mukaiyama esterification reaction is an esterification of carbonic acid using Mukaiyama reagent and alcohol in presence of base. Here base is used. Generally, acids are used for the esterification reaction. And this is the general reaction of Mukaiyama esterification reaction, where this carboxylic acid is condensed with the alcohol in presence of Mukaiyama reagent and base to give the esters. This is the general structure of Mukaiyama reagent. Mukaiyama reagent is nothing but the 2 halo 1 alkyl pyridinium salt, where this X is equal to chlorine, bromine or fluorine, and Y is equal to iodine, OAC, OCF3 and R is any alkyl group. And this is the commonly used Mukaiyama reagent, that is 2-chloro 1-methyl pyridinium iodide. You can use the variety of Mukaiyama reagent, but this is the commonly used Mukaiyama reagent. Let's see the mechanism of Mukaiyama esterification reaction. First, this carboxylic acid will react with base. This base will abstract the proton of the carboxylic acid and you will get the carboxylate ion. And now this carboxylic ion will attack on the Mukaiyama reagent. This carboxylic ion will attack on the second position of Mukaiyama reagent and you will get this intermediate. Then this lone pair of nitrogen will shift here and then chlorine will go out and you will get the two substituted pyridinium salt. And now this alcohol will attack on the carbonyl carbon of the carboxylic acid and you will get this oxyanion intermediate. Then this oxyanion intermediate will shift this negative charge to this carbon oxygen bond and it will break the another carbon oxygen bond and you will get this protonated ester. Then this pyridine 2-one will accept the proton from this protonated ester and it will give you the ester and 2-hydroxy N alkyl pyridinium salt. This is the mechanism of the Mukaiyama esterification reaction. The mechanism is very simple. You can prepare the variety of esters by using this Mukaiyama esterification reaction. Now the question will come in mind. Generally, these reactions are catalyzed by simple acids like H2SO4. Then why we need this Mukaiyama esterification? Because if your acid or alcohol contains any acid sensitive group, then we cannot use our general esterification reaction conditions. In that case, we have to use Mukaiyama esterification reaction. Here are the some simple examples of Mukaiyama esterification reaction. Here, when you condense this benzoic acid with ethanol in presence of Mukaiyama reagent and base, you will get the ethyl benzoate. Another example of this esterification reaction is thiophene 2 carboxylic acid and isopropyl alcohol in presence of Mukaiyama reagent and base, you will get the corresponding ester. Another Example of Mukaiyama esterification reaction is the reaction between acetic acid and cyclohexanol. In presence of Mukaiyama reagent and base, you will get the cyclohexyl acetate. You can write variety of examples. Here are the two more. When phenylacetic acid is reacted with 2-phenyl ethanol in presence of Mukaiyama reagent and base, you will get the corresponding ester. This reaction is also called intramolecular reaction, where the carboxylic acid group and alcohol groups are present in same molecule. And in presence of Mukaiyama reagent and base, you will get the cyclic ester that are called the lactose. Now, what is Yamaguchi esterification reaction? What is difference in Mukaiyama esterification and Yamaguchi esterification reaction? Reaction is same esterification. Only the difference is the reaction conditions. In Yamaguchi esterification reaction, carboxylic acids reacts with alcohol in presence of Yamaguchi reagent and DMF in presence of base. This is the general reaction of Yamaguchi esterification, where these carboxylic acids will react with alcohol in presence of Yamaguchi reagent, base, DMAP. You will get the ester. And this is the structure of this Yamaguchi reagent, that is 2,4,6 trichlorobenzoyl chloride. This is the structure of Yamaguchi reagent. First, this Yamaguchi reagent will react with the carboxylic acid in presence of base. You will get this mixed anhydride. Then this mixed anhydride will be attacked by this alcohol in presence of DMAP, and you will get the corresponding ester. Let's see the mechanism of this Yamaguchi esterification. The first step is same as Mukaiyama esterification reaction, where the base will abstract the proton and you will get the carboxylate ion. And now this carboxylate ion will attack on the Yamaguchi reagent, that is 2,4,6 trichlorobenzoyl chloride. This carboxylate ion will attack on the carbonyl carbon of this Yamaguchi reagent and you will get this intermediate. Then this oxyanion will shift here and chlorine will go out and you will get this mixed anhydride. Then this mixed anhydride will be attacked by DMAP, dimethylamino-pyridine. It will attack on the carbonyl carbon of the carboxylic acid, not on the carbonyl carbon of the Yamaguchi reagent, because this carbonyl carbon is sterically hindered due to this two chlorine atom present on the adjacent carbon, and you will get this intermediate. And then this oxyanion will shift here, then this carbon oxygen bond will break and this carbon oxygen pi bond will shift here and you will get that carboxylate ion and amide derivative. Then this amide derivative will be attacked by the alcohol and you will get this oxyanion. This base will abstract the proton and you will get this oxyanion. Then this oxyanion will rearrange and eliminate this DMAP and you will get the corresponding ester. This is the mechanism of this Yamaguchi esterification reaction. And these are the examples of Yamaguchi esterification reaction. When this benzoic acid reacts with cyclohexanol in presence of Yamaguchi reagent, DMAP and base, it gives the cyclohexyl benzoate. Another example is thiopene 2 carboxylic acid and ethanol in presence of Yamaguchi reagent, you will get the corresponding ethyl ester. Another example is acetic acid with benzyl alcohol. You will get the benzyl ester. This is the another example where you will see the intramolecular esterification, and you will get the cyclic ester, that is called the lactone.